Now today we're going to be learning about when there's more than one force. We're going to review what are balanced forces, review what are unbalanced forces, and we'll learn about net force. Raise your hand on Zoom if you remember what a balanced force is. Okay, Pasta rose his hand. Pasta was first. What is a balanced force?
A balanced force uh is when two forces are equal.
Very good. Exactly. It's when the forces on an object are equal. Good job, Pasta. And then who can tell me what unbalanced forces are? Puppy.
Unbalanced force is when the thing is it's not balanced.
It's not when something is not balanced or when the forces are not equal. And guys, today we'll be learning about something called net force. And we're actually going to use math and calculate net force, but it's just all you have to use is subtraction. So it's not going to be the hardest thing to calculate. You guys should all be able to do it, but that's what we're going to be learning about today. So we have balanced forces and unbalanced forces. Can someone remind me which one results a change in the object's motion? Let's have Taylor. Which one of these would result in a change in the object's motion?
This is a unbalanced force because if it's unbalanced force, the animals will not be equal. One is big, one is small, and it can move from this way to this way. It doesn't stay in one place.
Very good. You're correct. Unbalanced forces. And then which direction does the object move when the forces are unbalanced? So when forces are unbalanced, the object moves. But in which direction? Let's have Scart. Scart, which direction does that object move? An object moves when forces are not equal. It means one is bigger than the other. Which direction does the object move? Towards the smaller force or the bigger force?
Bigger force.
The bigger force, exactly. Okay, so we're going to have our definitions. Let's read them again. We have unbalanced forces. Sam, can you read unbalanced forces for the class?
When two forces acting on an object are not equal in size, we say that they are unbalanced forces.
And then can I have Jackie? Can you read balanced forces?
Okay. Balanced forces are equal in size and opposite direction. When forces are balanced, there is no change in motion.
Very good. And can someone give me an example of an object that has balanced forces in their room? Ray. Ray, can you give me an example in your room that is balanced right now?
The iPad is balanced.
How do you know it's balanced?
Because it doesn't move.
Because it's not moving. Very good. Now, we'll get into it later, but balanced forces can also be moving, but they can't be changing. So they have to be staying the same speed. They can't be getting more force either forward or backward. So like maybe an object in space could have a balanced force as well, but it's very rare that something that is moving to have balanced. But yeah, your iPad is a great example of a balanced force. My cup, my coffee cup is a balanced force. It's not moving unless I move it. Okay, so let's do a little bit of a concept builder. Now, we have an N equaling a Newton. It's just a measurement of force. Now, let's have someone read about a Newton. Very good. So that's just how they measure force. It's how we calculate and measure force. Nothing complicated. You guys don't need to know that for a quiz or anything, but if you see the capital letter N, you know they're talking about force. Let's look at some examples. So we're going to circle the larger force. Everyone, I want you guys to get ready to circle the larger force. Now, remember, this N is the amount of force. Which one of these forces do you think is larger? Circle in 3, 2, 1, go. Sarah, Sam, Taylor, Moon, Ray, good job. Blue Moon, Bunny, Taylor. Oh, that's too many names. Milk, Pasta, Emma, Bunny, good job. And then our next one in 3, 2, 1, go. You guys got that down. You guys got that down. Yeah, it's just the bigger number. 7N is more force than 5N. If I push something with 7N, it will go farther than if I push something with 5N. If you guys really want to know what the N stands for, it's okay if you don't want to know, but if you want to know what the N stands for, it's how much force it takes to move 1 kilogram object to the speed of 1 meter per second. I know that's complicated, but if you wanted to know what N stands for, it's basically how much force is needed to move an object. So let's look at it, move an object. Now we have a car, okay? Will this car move to the left or to the right? What do you guys think? To the left or to the right? Circle your answer. Okay, look at the car, look at the arrows with the force, and try to figure out if where this car is going to move, to the left or to the right. You guys can circle in 3, 2, 1, go. Okay, you guys all got it. Good job. Now let me call on one of you. Let's have Blue Moon. Blue Moon. How'd you know it was going to move to the right?
Because the right is more Newton.
10N is larger than 8N?
Yes.
Yeah. And when an object, the object always moves in the motion of what? The larger force or smaller force?
Larger force.
The larger force. Very good. Good job, guys. Let's do a few more examples. Let's see if you guys can do more. Ready? Left or right now, the numbers have changed. Let's draw in 3, 2, 1, go. Left or right, guys, left or right. Let's not circle the numbers. Puppy, good job. Ray, good job. Lisa, good job. Misha, good job. Okay, guys, let's make sure we're just drawing a circle around left or right. You guys are getting a little crazy. Left is correct. 20N is larger than 10N. And finally, is it going to go left or right? In 3, 2, 1, go. Okay. Yeah, it's not going to go left or right. Why, Lisa?
Because the forces are equal.
Yeah, the forces are balanced or equal. Thank you, Lisa. Lisa got it. Exactly. When your forces are equal, the object is not moving. And our last one in 3, 2, 1, go. I think you guys got this. Let's see who's first. Who's going to circle the left or right? Sam, I think, was first. Good job, Lisa. Sam, Banana, good job. Blue Moon, Ray. Blue Moon would have been first, but he circled the number and not the left or right. Good job, guys. Let's do a little bit of reading about balanced and unbalanced forces. Good job. Taylor, can you read for us?
Carefully balanced. Pairs of force are either balanced or unbalanced. Balanced forces are the same size and so.
Jack Vu, read the next sentence for us.
When one force is stronger than the other and the force acts in different direction, they are unbalanced force.
Exactly. Okay. So this is kind of like the dog and the toy and the balanced rock example. Okay. Who can read the first picture for me? Let's have Alex. Can you read the first picture for us?
The two dogs are evenly matched. They both pull with a force of 10. The X marks the center of the rope at the start. The rope has it moving, even tough. Two, both dogs are pulling.
What's this an example of, Alex?
Balance
Yeah.
force.
Yeah. Good job, Alex. Alex got it correct. And let's have, make sure I call on everyone here. Let's have Cherry.
Now one dog is playing tug with a big horse. The horse is stronger and pulls with a force of 14. The dog will be pulled over the edge in the direction of the horse.
Yeah. And what's this an example of, Cherry? Is this a balanced force or unbalanced? What do you think, Cherry?
Unbalanced.
Yeah, unbalanced. Okay. We don't have to read it twice. We can read about net force. Okay, let's learn our new word now. Sino, can you please read about net force?
Add all the forces that push or pull on an object. This sum is called net force. If the animals pull with equal force, the force of balance. This is a zero net force. The motion does not change.
Very good. So we have to add all the forces together. And this can be a little confusing because adding the forces together is sort of like subtraction. And I'm going to show you why. But basically when there's a force in the opposite direction, it's almost like it works like a negative to the other force. So you have to actually subtract them to get the correct answer. Right? Now, what would be the net force of this vehicle? Kim, do you have a guess of what the net force is if we add these forces together? And remember, they're going in opposite direction. Okay. No. So let's read the sentence. So if the forces are balanced, this is zero net force. So how much net force does our car have?
I don't know.
Okay, that's fine. So guys, the net force of this car is 0. And the best way to look at this is, I'll write an example. So let me get some white, let me get my text. So for this one, we're gonna have to we have to add these forces together, okay? We have to add these forces together. Now, they're both going in opposite directions. So what I would like you guys to do is just do 5 minus 5. You have to subtract, always subtract the smaller force from the larger force. So we have 5 minus 5, okay? And this is gonna give us an answer of 0, okay? So our net force is 0 net force, okay? Net force is what happens when you take all the other forces into consideration, okay? And this might be a little confusing, so let's look at another example. Okay, Taylor, what do you think our net force is?
It is 20.
It's 20, and is it going to the left or the
This
right?
is 20 net force.
Yeah. Is it
This is going to the right.
It's going to the right. Exactly. Because basically, when you have two forces, they cancel each other out. Because this is 20N, it's going to get rid of 20N over here. So Taylor got it right. 40N minus 20n equals 20n. Okay, that's all the math that is required to do this, okay? Is to calculate net force. The answer is net force. So this car, once we're done, let me get rid of this, show you an example. Let me get rid of this line. Our answer would look something like this. So this would be our answer. The car is moving 20n and it's going to the right because we got rid of that force in the back. Okay, we calculated for it. Okay, this is net force. This is still page 91 of your book. Okay, so if you guys have your book, you guys can follow along. Okay, this is homework 2 nights ago. So we have force A and force B. Which one is going to be our winner, the big horse or the big horse? Emma, which one is our winner? Okay, so we have force A and force B. Look at our chart. We have a big horse and a big horse. Which one is going to be our winner if they have a tug of war match? If they have a tug of war match?
No one is a winner.
No one, okay? And is this balanced or unbalanced?
Balance.
It is balanced. Very good. Okay, and then we have a big horse versus a elephant, an adult elephant. Misha, which one do you think is going to win our tug of war? Let's have Rose. We're having a tug of war against the big horse and the adult elephant. Who is going to be the winner?
It's a adult elephant.
An adult elephant. Okay, let me write that down. And is this balanced or unbalanced?
Balance.
Unbalanced. Yeah. Very good. So check your answers in your book, guys. For the winner, you can also put the big horse because that, no, you know, it's okay. Let's continue. Now let's review what we've learned today so we can go over your homework. Your homework is going to be a little bit hard, okay? So I want to be able to make sure we spend some time going over your homework. So what we have learned today, what is a balanced force? Sophia, what is a balanced force?
A balanced force is the two number of forces that equal.
Exactly. And can you read the answer for me?
When the forces acting on an object were equal.
Good job, Sophia. You got it correct. Okay, number 2, what is a unbalanced force? Jackie, what is a unbalanced force?
An unbalanced force means when an object pulls or push it's not equal.
Yeah, when it's not equal. Jackie, can you read the answer for me?
When the force acting on an object are not equal.
Good job, Jackie. You got it correct. And number 3, what is a net force? A net force. How about banana? What is a net force?
One use can add all together the remaining force in the net force.
So once you add the forces together, the remaining force is the net force. And the way you want to think about it is the arrows change if it's like a negative number or not. Okay. And your homework for tonight. Okay. Let me show you your homework. Let me click on it real quick. We can look at it. No worries. Okay. If you have any questions, we have time to explain them now. Your homework is to finish 1 through 10 of this worksheet. The first thing, calculate the net force, and I want you guys to write the answer as well as the direction. So let's look at examples. This is question 1 and question 2 of your homework. And remember, just use subtraction. So number one, what is our net force? What is our net force? Let's have Daisy. Could you help me with the net force? Now, how many forces are acting on this object, Daisy?
4.
4. Yeah, 4n. And which direction is it going? To the left, or
Left.
to the right? To the left. So because there's no other forces, we only have to do 4 minus 0. What is 4n minus 0? N, Daisy? What is 4 minus 0?
4.
4. 4n. Very good. So our answer will be 4n. And you said to the left. So I will write to the left.
To the left.
There you go. That's all the answer is. That is the net force. Now let's look at number 2. Number 2. This time you're going to have to subtract. Let's have Sarah. Sarah, can you subtract these for us and then tell us the net force? Okay, Sarah, so what is the larger force? 7n or 2n? 7. So we write 7n. And now we subtract the smaller force. What's the smaller force?
2.
2. And this equals, what's 7 minus 2?
Equal 5.
5. Very good. So our net force is what?
Answer is 5n.
Yep. And is it going to the left or to the right? To the left. Very good. So guys, this is how you complete your homework. All you have to do is subtract. And if you don't want to write the n, it is okay. If the n is confusing you guys, I'll show you without it. It is just 4 minus 0 equals 4. And this one is 7 minus 2 is equal to 5. So this is all the math that is required. Remember, the forces are going in opposite directions, so they cancel each other out. Now, anyone have a question? Okay, guys, this is your homework then. That is it for today, guys. I hope you guys have a great Monday. You guys just have to complete 1 through 10. Remember, subtract the forces from each other, and that will be your net force. The net force is just the remaining force after you calculate all the different directions.